Hey everyone, and welcome back to The Explainer. Today we're looking at a truly fascinating case study of technological self-reliance. We are diving into the GIDS Uqab drone program. This is the story of how a nation, faced with heavy international restrictions, actually managed to build a homegrown, tactical unmanned aerial vehicle, or UAV, completely from the ground up. It's honestly a masterclass in adapting to limitations, and I am super excited to get into this one.
Okay, let's dive into this. Picture the situation. How do you build an advanced drone when you're literally cut off from the technology? Back in 2007, the United States heavily restricted technology transfers under the Missile Technology Control Regime. And for Pakistan's military, well, this created a massive intelligence gap. They couldn't just buy advanced drone systems off the shelf anymore. They needed eyes in the sky for their complex, rugged terrains, and they needed them fast. So necessity really became the mother of invention here.
So here's our roadmap for today. We'll start with the spark of indigenous innovation, then break down the Uqab's engineering and flight capabilities. After that, we'll see how it secures vital infrastructure and science, track its evolution into naval operations, and finally, look at how it's disrupting the global defense market. All right, kicking things off with Section 1, the spark of indigenous innovation. What's really striking here is the sheer speed of this development. The project kicked off in 2007, spearheaded by Global Industrial and Defense Solutions, or GIDS, and just 1 year later, March 20th, 2008, they pulled off the first successful test flight of the baseline Uqab. By 2011, it wasn't just an experimental Army asset anymore. It had been formally inducted into the Pakistan Navy. That is a rapid turnaround. The whole point of this program was, and I quote, filling critical reconnaissance gaps after restrictions on technology transfers. The Uqab wasn't built to be some luxury showcase item. It was a direct, homegrown solution to a very immediate tactical problem. They took what they knew from earlier local systems and built something entirely customized for their own strategic needs.
Okay, let's move to our second section, engineering and flight capabilities. Let's see what these machines can actually do.
Take a look at this. This is the compact, fixed-wing airframe of the baseline GIDS Uqab. You'll notice it's built primarily from low-cost composite materials. And that's a brilliant engineering choice, honestly, because it makes the drone lightweight, highly durable, and it dramatically reduces maintenance costs over time. This original model uses a pusher-propeller configuration and relies on a pretty conventional wheeled system for takeoff and landing. To put its size into perspective, it's just 4 meters long, with a 5.5-meter wingspan, so it's highly compact. It cruises quietly at about 150 kilometers per hour to minimize detectability. But the really key metric here is that 150-kilometer communication range. If you're running a short-range tactical mission, that is exactly the footprint a field commander needs to see over the horizon without having to rely on massive, expensive global infrastructure.
Now, what's really interesting about this next detail is the endurance. 15 hours. While the early models hovered around a 6-hour endurance mark, reports indicate that a later Uqab variant boasts a flight capacity of 15 hours. Couple that with reports that it can actually carry up to 1,000 kilograms of ammunition, and you're looking at a massive leap in operational capability from where they started.
And that evolution perfectly illustrates how the platform matured into the Uqab NG, or next generation. Notice the launch system on this one? This variant doesn't even need a runway. It uses a catapult launch and a net or parachute recovery system, meaning it can be deployed almost anywhere. It pushes the service ceiling all the way up to 18,000 feet, features dual redundant flight controls, and it even optimizes the radar cross-section to make it harder to detect. It is built to survive in rugged, unpredictable environments.
But, the eyes and brains of the Uqab are equally impressive. It carries a gyro-stabilized sensor suite packed with color daylight cameras and thermal imagers, so you get 24/7 day and night surveillance. It can actively track and lock onto moving targets using a real-time video downlink. And thanks to its GPS and inertial navigation systems, operators can pre-program up to 1,000 waypoints for fully autonomous missions. All right, Section 3, Securing Infrastructure and Science. We know it's a capable machine, but how is it actually being used out in the field?
Think about this logistical nightmare for a second. How do you practically monitor thousands of miles of vital resources, like gas pipelines, when they're stretched across totally unforgiving, mountainous terrain? Trying to do that on foot is nearly impossible, and using manned helicopters? Well, that's a great way to absolutely bankrupt your defense budget.
The Uqab provides a really ingenious answer to this.
Out of the box, the base remote control limit is around 250 kilometers, right? But the system utilizes satellite connectivity to effectively bypass those range restrictions, allowing operators to monitor assets nationwide. And the people flying these things are doing it from highly mobile, truck-mounted, air-conditioned ground control stations. You can drive these trucks right into rugged field conditions, get real-time telemetry and video, and you don't even need to be plugged into a vulnerable external power grid.
So this technology is actively deployed right now to protect major economic lifelines. It provides a literal unblinking eye over the CPEC-SUI gas pipelines, massive national dams, sensitive installations, and remote borders. The Uqab acts as a constant sentinel over critical assets that keep the nation's economy running.
But here's a really cool pivot. It's not just a military or security tool. Because of its highly reliable sensor payloads, the Uqab is actively utilized for scientific research, climatic and weather analysis, and even crucial flood relief operations. It's proving to serve humanitarian and scientific needs just as effectively as the tactical ones.
Moving on to Section 4, Evolution to Naval Operations. Let's see how this transitions to the open ocean.
The journey of this drone across different military branches is a textbook example of maximizing a technological asset. Step 1. The Army originally deployed the Uqab P-1 for land border monitoring and artillery correction. Step 2. To make it seaworthy, the National Engineering and Scientific Commission stepped in with major electronics upgrades for greater aerodynamic stability over the water. And finally, Step 3. On July 20, 2011, this culminated in the induction of the Uqab-2 into the Navy, officially establishing the 47 UAV Squadron at PNS Mehran in Karachi.
It's actually a really interesting contrast when you look at how the different branches use the exact same foundational tech. Over land, the Army uses it for things like artillery correction and battle damage assessment in super rugged tribal areas. But out over the water, the Navy uses the Uqab-2 for persistent coastal surveillance, patrolling creeks, and running anti-smuggling and counter-narcotics operations over the Arabian Sea.
All right, Section 5, Disrupting the Global Market. We've seen what it can do locally, now let's zoom out to the macroeconomic picture.
To understand the disruption here, you kind of have to understand the monopoly. Historically, Israel has controlled a massive 60% of international UAV exports. Alongside Chinese systems, the global tactical drone market is heavily dominated by just a few major players who essentially act as Goliath. They set the prices and they set the rules.
So the crucial point is this. Global standards usually mean incredibly high acquisition costs, restrictive export rules, and a reliance on foreign infrastructure. The GIDS Uqab completely flips that script because it's built with indigenous composite materials and features a low-maintenance, modular design. It offers a highly cost-effective, entry-level system for nations that want to build a dedicated UAV squadron without totally emptying their wallets.
And the global market is absolutely taking notice. The UAE, Bahrain, Indonesia, Egypt, and Turkmenistan have all submitted applications or expressed serious interest in acquiring the Uqab system. They're out there looking for economical, reliable alternatives for short-range tactical operations, and this homegrown Pakistani system fits the bill perfectly.
Which brings us to our final thought. As more and more nations seek affordable autonomy and try to step out from under the restrictions of legacy superpowers, will indigenous systems like the Uqab fundamentally redefine the future of the global defense market? It's a fascinating shift in power dynamics driven purely by technological self-reliance, and it's definitely something to keep an eye on. Thanks so much for joining me on this explainer. Keep questioning, keep learning, and I'll catch you in the next one.